Welcome to the Deep Dive. This is where we take a whole stack of sources and really pull out those key insights, those moments that, help you understand what's really going on. Today, we're plunging into a market that might, well, fly under the radar for most people, the global Sialon powder market. Sounds a bit technical, maybe, but it's an industry that's absolutely essential to so many modern technologies, stuff that impacts your life, really, even if you don't see it directly. Okay, let's unpack this.
Indeed. Yeah. Sialon powder, it's probably not something you hear up every day, but it's a critical advanced ceramic. Think of it like a super tough blend, basically silicon, aluminum, oxygen, nitrogen, all mixed together. And what's really interesting are its properties. It's incredibly hard, very strong, resists wear and tear extremely well, and it handles heat like a champ.
Right.
And that makes it vital for, high performance things, cutting tools, for example, the ones used in really precise manufacturing, or wear resistant parts in heavy duty industrial machines, and other advanced ceramics, think aerospace engine, even some medical devices. So, yeah, that's why this market, even though it seems niche, is actually globally quite important.
Right. And for this deep dive, we're working with detailed market revenue forecasts from cognitive market research. Our goal, like always, is to give you the big picture and most important takeaways without getting totally bogged down in every single data point. So, to set the scene, let's look at the global numbers. The market was worth just over $300 million back in 2021. That's projected to climb past $410 million in 2025. And then look at this, a pretty big jump to nearly $750 million by 2033. That works out to a compound annual growth rate, a CAGR, of 7.8%. That seems, well, that's some serious consistent growth for a material most folks haven't heard of. What's your immediate take on that?
Well, it tells me straight away that the demand here isn't just some fleeting trend. It's foundational. We're not looking at a boom and bust situation. It's a steady, ongoing need for Sialon, precisely because it's essential in industries that are themselves growing and needing better, tougher materials. And when we start breaking it down by region, you really see how that global picture plays out differently across various industrial scenes.
Absolutely. Okay, let's kick things off with North America. Its market is forecast to more than double, going from nearly $100 million in 2021 up to over $240 million by 2033. The U.S., as you'd probably guess, is the main driver there, responsible for most of that growth. Canada's a solid player too. But here's something that caught my eye. Mexico. Okay, it starts from a smaller base, right? Just over $3 million in 2021, but it's projected to hit nearly $10 million by 2033. That's almost tripling. What do you think is happening in Mexico to cause that kind of percentage jump?
Yeah, that surge in Mexico, even off a smaller base, it's a really good indicator. It suggests focused investment in specific industrial areas, probably high precision manufacturing, maybe automotive, maybe electronics, sectors where Sialon's hardness and wear resistance really pay off in production efficiency, especially when working with newer advanced materials. Kind of points to demand broadening out, new industrial centers starting to emerge beyond the usual giants.
Interesting. Okay, let's shift across the Atlantic. Europe, also looking strong, set to grow from about $87 million in 2021 to over $208 million by 2033. Germany, maybe not surprisingly, shows really robust growth, more than doubling its market size. The UK, France, Italy, Russia, all significant contributors. But the rest of Europe category, now this is a fascinating little nugget. It sees an almost four-fold increase, jumps from under $8 million in 2021 to nearly $30 million by 2033. What does that kind of dispersed but really accelerated growth tell you?
Ooh, that rest of Europe figure is highly insightful. It strongly suggests that Sialon adoption isn't just happening in the big established industrial economies. Instead, you're seeing this distributed but rapidly growing integration of Sialon applications across lots of smaller economies, or maybe specialized industrial sectors within the continent. Could be niche manufacturing, could be emerging tech, maybe even specific energy projects that need these high-performance materials. It really signals a broader and deeper industrial modernization happening across Europe.
Okay, moving over to Asia Pacific now, another powerhouse region, especially for advanced materials. Its revenues projected to more than double too, from around $80 million in 2021 to over $200 million by 2033. China is clearly way out in front there, really cementing its role as a global manufacturing hub. Japan's still a major player, of course, but India was showing a real surge, more than doubling its market share over that same period. South Korea, Australia, Singapore, Taiwan, all trending up. And Southeast Asia alone is projected to reach over $15 million by 2033.
Well, the rapid industrialization and the tech advancements across Asia Pacific just create this built-in growing demand for materials like silo. It's almost inherent. India's growth spurt specifically likely points to significant government pushes, investment in advanced materials R&D, maybe localized aerospace and defense manufacturing. Those are sectors where Sialon is absolutely critical for high-performance components. It underscores that strategic move towards more self-reliance and high-tech production capabilities.
Right. So if Asia Pacific is kind of the leading edge of industrialization, what about South America? The growth there is slower, but it's still steady. The market, while smaller overall, is still projected to more than double, nearly $13 million in 2021 to over $27 million by 2033. Brazil's the biggest piece of that pie. What's the story there?
Yeah, the absolute numbers are smaller compared to, say, Asia or North America, but that consistent doubling in South America, especially led by Brazil, it does indicate a developing industrial base, one that's increasingly bringing in these higher performance materials. It probably suggests a focus on sectors like mining, maybe agriculture, infrastructure projects, places where Sialon's wear resistance can make a big difference in the lifespan and efficiency of heavy equipment.
Okay. And the Middle East, another region showing strong growth, projected to nearly triple, actually, from about $14.5 million in 2021 to over $41 million by 2033. Leading countries there are Saudi Arabia, Turkey, UAE, Egypt. In a region so often linked just with energy, what kind of diversification might be driving this need for Sialon?
That's a great question. This growth very likely ties into those broader economic diversification plans we hear about across the Middle East. There's a clear emphasis on building up sectors beyond oil and gas, right? Things like advanced manufacturing, major infrastructure builds, even renewable energy projects. And in those kinds of areas, Cylon's ability to resist corrosion and wear is really valuable, especially for parts operating in tough conditions. Think specialized drilling gear, refinery components, maybe even parts for solar power installations.
Makes sense. Okay, finally, let's look at Africa. The market there is projected to almost triple as well, growing from under $10 million in 2021 to over $25 million by 2033. Nigeria and South Africa seem to be leading the way, with South Africa alone expected to reach over $11 million by 2033.
Yeah, this growth in Africa, particularly in places like Nigeria and South Africa, points towards emerging industrial sectors and quite significant infrastructure development. These economies are clearly moving towards using more advanced material solutions. They need to build systems that are robust, efficient, whether that's in resource extraction, manufacturing, or, power generation. It's definitely an indicator of some fundamental economic shifts starting to happen.
So if we pull it all together, wrapping up what we've seen today, it's just a clear, consistent, global rise in demand for Sialon powder. No question about it. And that growth is absolutely being driven by its vital role, really a foundational role, in advanced ceramics, cutting tools, wear-resistant components. It's like a hidden backbone for so much modern industry. The numbers really reflect that steady, unwavering need.
Exactly. And digging into that granular data, it reveals something, I think, a bit deeper than just market growth. You see these specific regional surges, like Mexico almost tripling its share, or that incredible fourfold jump in the rest of Europe. These aren't just isolated numbers. They really illustrate how industrial landscapes are evolving, how niche demands are popping up, sometimes in places you might not expect. It just shows the critical role Sialon plays in enabling manufacturing efficiency and tech advancement everywhere, really from the ground up.
It's truly fascinating, isn't it? How these materials markets, the ones most people never think about, are quietly, indispensably underpinning so much global industrial progress. Makes you wonder what other hidden essential materials are out there, quietly shaping our future, enabling that next wave of technology, manufacturing, infrastructure, things we rely on every single day. Something to think about. Keep digging, keep exploring, and stay curious about those unseen forces driving the world. We'll get you on the next deep dive.
Okay, let's unpack this. Welcome to the deep dive. Today, we're looking at something pretty specific, but really interesting, Sialon powder. It's part of that advanced ceramics world. Our mission for you today, to really get under the hood of this stuff, understand why it matters, what makes it tricky, and, well, where it's heading.
Exactly. And Sialon, well, the name stands for silicon aluminum oxynitride, but fundamentally its promise is all about performing incredibly well in really, really tough environments, high-performance situations. It genuinely pushes the limits of material science.
Right. So if it's that good, why are industries starting to really pay attention now? What's driving them to, adopt Sialon? What's the appeal?
Well, it's not just one thing, it's the combination. You've got incredible strength, really superior thermal stability. It handles heat exceptionally well. Plus, it's very resistant to wear and corrosion. These aren't just specs on a sheet. They mean you can do things you couldn't before.
Like what specifically? Where are we seeing it used?
Okay, so think aerospace and defense. Because it's light and heat resistant, it's great for things like turbine blades, also structural reinforcements, thermal barriers, places where weight and heat are critical. Then you've got metal forming, cutting tools. Its hardness, its resistance to thermal shock, it just means tools last way longer and they're more precise.
Okay, that makes sense for a heavy industry. What about other areas?
Yeah, electronics and semiconductors too. It's becoming really important for high precision bits. Things like substrates, insulation, components for high frequency circuits, especially, as everything keeps getting smaller and more powerful.
Wow, okay. So it sounds almost like a wonder material, opening up new possibilities. But like you always find with advanced stuff, there's got to be downsides, right? Hurdles. What's stopping it from being absolutely everywhere if it's that good? What are the bottlenecks?
That's the flip side. Absolutely. It's a classic case.
Hmm?
The things that make it amazing also make it, challenging. And expensive, the biggest hurdle. Definitely the manufacturing and processing costs. Making Sialon needs very controlled conditions, expensive raw materials. So yeah, top performance, but top price too.
Uh-huh. Cost is always a factor. Anything else?
There's also, surprisingly, just limited awareness. And the technical know-how needed to work with it isn't widespread yet, especially for, say, smaller companies. They might not know its potential or how to integrate it. And look, it faces competition. Materials like alumina, zirconia, they might not be as good in every single way, but they're often good enough for many uses, and they're cheaper.
So existing alternatives can do the job for less, sometimes.
Sometimes, yes. And one more thing. Actually shaping Sialon after it's been centered, heated, and pressed into that super hard solid form is really complex. You need very specialized, expensive tools to machine it properly.
Okay, so significant challenges. Cost, expertise, competition, and just the difficulty of working with it. But it sounds like things are changing. What developments are helping to overcome these hurdles? What opportunities are opening up?
Oh, definitely. There's some really exciting stuff happening. A big one is additive manufacturing, 3D printing. This is kind of a game changer because it gets around some of that difficult machining. You can create really complex custom Sialon parts. We're seeing huge interest there, especially in aerospace and even biomedical fields.
Ah, printing it directly into shape. Clever. What else?
Well, there's growing demand from renewable energy sectors. Think about solar, wind, fuel cells. These often involve extreme conditions, high stress. Sialon's toughness and stability are really valuable there. We're also seeing innovation in hybrid materials. So mixing Sialon with other things like different nitrides or carbides. The idea is to maybe boost properties like fracture toughness, making it less brittle, or even add electrical conductivity.
Tweaking the recipe, basically.
Kind of, yeah. Tailoring it. And finally, there's a big push, driven by sustainability goals, to make the production of Sialon itself more energy efficient and cleaner, lower emissions.
Right, the whole life cycle. So we've dug into Sialon powder. It's clear there are obstacles, mainly cost and complexity. But its core properties are just so compelling. And with innovation in manufacturing and new applications emerging, its future looks pretty bright.
It really does. And it leaves you with a thought, doesn't it? As material science keeps advancing, you have to wonder, what other, maybe unexpected industries could materials like Sialon quietly start to revolutionize next? Where else could these properties make a difference?
That's a great question to ponder. Keep exploring, keep thinking about the materials shaping our world, often behind the scenes. Thanks for joining us on the Deep Dive.